Okay, hello everyone, and welcome to today's session, Four-Dimensional Automation, Reshaping Optical Networks New Smart O&M. This session is part of Huawei's User Group Meeting 2020. My name is Colin Robinson, and I'm from Huawei, and I'm happy to be joined today by 5 industry experts working in the optical network field. Now, throughout the event, if you have any questions, feel free to submit them in the question box on the right-hand side of the screen. And after we've heard from our speakers, we'll conclude with a short question and answer session. So make sure you're around for that. Right, let's get started. So joining us today, we have, and in no particular order, Ian Redpath, practice leader at Omdia, formerly known as Ovum, Henry Cho, Chief Technology Officer and Director of Huawei's Network Cloud Engine Products, Kawanan Pachanun, who is Vice President of Thailand's CAT Telecom, Yin Zhang, who is Director of the Transport Network Center at China Unicom in Beijing, and finally Jingming Shi, who is Director of the Transmission Office for China Unicom in Jiangsu. Okay, let's begin by hearing from Ian Redpath, who is about to explore fresh insights for the optical network industry, including the continuing evolution toward automation. Okay. And let's put Ian on the line now.
Hello, this is Ian Redpath,
Okay.
Practice Leader for Components, Transport, and Routing at Omdia. On to slide 2, I would like to introduce Omdia, a new market research and consulting firm just launched in the first quarter of this year. 2 long-standing market research houses, Ovum and IHS Markit, came together to create Omdia. Slide 3, the agenda of my talk today is network management for optical networks. I will focus on optics, but I will weave in a few multi-layer concepts. I will start with the evolution of the digital economy and interconnection bandwidth, and then I'll move on to network management trends. So some of the key trends right now are automation, prediction, and prevention. And then what can software do for the optical network in the future in terms of network intelligence and control and automation? And then finally, artificial intelligence. We've been hearing a lot about AI. AI has emerged as a network topic over the last few years. Where does AI fit in the context of optical networks? On to slide 4. Now, we all know that the digital economy has been growing, and for many of us, we have utilized digital more and more than we ever have in the past over the last few months. So to me, there's 2 foundational elements to the digital economy. There's the application side with compute and storage, and then there's the network side and the bandwidth that interconnects it all. So early days of cloud service in the digital economy, there was much promise, but maybe in cases a little bit short on actual performance. We did have cases where the distance between the end users and the data centers was substantive, and it was delivered with maybe not the best bandwidth solution. Internet access was used often in cases, and so then you had the standard internet access challenges, best effort not guaranteed, no defined latency, and just plain old bandwidth limitations. So a lot of promise in the early days, but maybe a little bit short on performance. On to slide 5. Now, with the growth of the digital economy and the growth and adoption of cloud services, we have heightened expectations for performance. So the digital economy is underpinning significant portions of the entire global economy. Corporations and millions of their white-collar staff have shifted operations to a digital mode. So how can we take a step up and deliver the performance that we need? Well, one way is to improve the whole edge cache CDN side of the equation. So effectively more edge sites and more of those edge sites closer to the consumers and the corporate users. The benefit here is closer proximity. It allows lower latency. And the second way to improve the overall performance is on the bandwidth side. So evolving from a best effort model to really much more of a private line style model. So enabling latency certainty for not only the primary path, but also the failover path. So we need to move to a new era, enable bandwidth certainty, guarantee bandwidth for applications and user requirements, and higher bandwidth overall. On to slide 6, and shifting the discussion to O&M and the future of O&M. So CSPs may be at different points on the automation journey. CSPs might not even be able to begin the automation journey if they lack clarity on inventory. Inventory is a key foundational piece. So we do have inventory systems, so what's the problem? Well, the problem can be just that, systems as opposed to one unified system. CSPs may be relying on costly and error-prone manual processes. CSPs may have inaccurate data in their inventory systems. The inventory systems may be disparate across the network layers. Network inventory may have discrepancies relative to the OSS and BSS systems. So getting the inventory system squared away is a key element before we can even really start the discussion on automation. Slide 7, automation. So CSPs may have many and multiple objectives pertaining to automation. Some objectives may be to improve the customer experience, to improve customer retention. So that's a pretty straightforward goal. Other goals might be to improve operational efficiencies, really to focus on OPEX cost and to bring down OPEX cost. So, save time, save internal resources, and then that leads to an OPEX savings. And then uptime. Uptime is always mission critical, and it's critical for customer satisfaction. So in one particular CSP case, the CSP was relying on Excel for network management records. They did not have a central database of everything, and they had no developed depository. And then they also struggled to tie information together for restoration activities without having a clear view of all their inventory and where everything was. And then at the same time, their network was growing. It grew substantially, and they really required a network database solution. So they'd reached a point where they needed to move on to a next generation operational system and operational paradigm. And for them, it was not only about cost savings, but it was also about protecting revenue and growing revenue in the future. Slide 8, on to fault prediction and prevention. So another major CSP challenge is to shift from a reactive network maintenance model to much more of a predictive model. So fortunately, we do have a couple of key hardware enablers here. So OTDRs, if we think about the OTDRs of the past, they used to be very, very large and expensive. So that led to their deployment in very select points in the network and not very many of them. And then, as time has gone on, the industry has managed to shrink OTDRs in terms of physical size and footprint, and cost has come down significantly. So this has really enabled another paradigm shift where OTDRs, while maybe not quite completely ubiquitous, they are now deployed in many, many more points in the network. And this just enables operators to capture optical parameters from very, more and more points in the network. So capturing power levels, capturing bit error rate, and these are great indicators for performance of the optical layer. In addition to the OTDR side, there's the silicon side. So fault generation is basically a capability that's now embedded into silicon. So telemetry data can be pulled off of the coherent chipsets. It can be pulled off of the switching ASICs. And so this data is just generated right at the chip level. And again, a vast, much larger volume of data can be generated, many more parameters, providing much more insight into the health and state of the network. So in addition to more data, there's also the time series element of the data as well. So an historic practice was to keep telemetry data for very short intervals and then basically dump it. But now the view is a little more mature, and it's keep that longer time series data. So now there's a bigger historical record of the data in the network, and with this larger historical record and more data points, it gives a much bigger foundation of data, and sets us up to sift through that data and find interesting trends that are impacting the network over time. And with that foundation, then we can use that to make predictions. And with the enhanced prediction capability, we can move from that reactive state of fault management and move much more to a proactive state than we've had in the past. So, take actions as things are degrading, but not quite yet service affecting, and that gives the users a much better user experience, and it's also a more efficient way to operate from an operator perspective. If you know that something is coming, then you can line up the resources a little bit ahead of time, have them in place, and move them over, and it's less of an emergency reaction kind of scenario. So slide 9. So software is really the glue that ties this all together now. So adding software intelligence to the power of optics. So now we do have orders of magnitude more information in the network today, and we can effectively create a digital twin of the network within the network management system, another foundational piece. And we've got accurate multi-layer inventory management with real-time awareness. We now have more refined control and automation capabilities. So, for example, back to the threshold setting case, thresholds can be set and, to identify congestion as it's building, but not quite to the point of actually triggering a service-affecting fault. So we can get to much more of a proactive stance, which gives us the benefit of capital and operational efficiencies. And then another item that can be approved upon is, evolving from the offline planning to online planning scenario. With that integrated, you remove that one step where there can potentially be some data inconsistencies. Slide 10. At Omdia, we do like to take the pulse of the CSP community. So one recent ICT survey we reached out and we heard back from 420 folks within the CSP community. So the survey question was, how important are IT projects to your company? And the red bars indicate important and the gray bars indicate very important. So I won't go through the totality of the list here, but 3 IT projects did score very high. So the first one was using analytics to support network operations. The second one was intelligent end-to-end customer engagement solutions. And the third was applying AI and machine learning to operations. So it's nice to see that the carrier community is aligning with some of our thinking here at OVM. And these are all pretty important trends from our perspective as well. So we really see intelligence and automation playing a more critical role in transforming CSP operations. Slide 11. So one of the great powers of networks is to be able to get to everyone on the planet. But in order to get to everyone on the planet, it can't be done by one carrier alone. It requires multi-carrier. So this is where the whole automation discussion really takes a much more interesting twist. The whole idea of multi-carrier operations and moving to an automated world in that case. So what is the current state of some of the OSS and BSS initiatives in the multi-carrier context? So back to the starting with the objectives, the CSP objectives are to automate multi-carrier interconnect in terms of access tails. Many of the global carriers have been down on this path for years and years, and it's really about being able to rapidly turn up those last tails for their global customers and do it in a quick and cost efficient manner. And then another objective is to automate Cloud Connect. And you know, in today's world, it's usually not just connecting to one cloud, but connecting to multi-cloud. So in terms of the current state, CSPs are really beginning to automate quoting and ordering in the multi-carrier case and the multi-cloud case. So that's just beginning these days. And then a future state, which would take it yet one step further, is automated federated provisioning. So this will probably roll out in phases as well. I expect to see the federated provisioning to roll out in, perhaps a data center to data center case, early days, and then evolve to the more complicated and complex end user to end user phase. So, once you get end user to end user, you're adding in a bit more CVE complexity. It just makes the puzzle a little bit harder to solve, but folks are actively working on that today. So kind of coming back to the CSP benefits, with these types of automation, it leads to faster service turnup, and faster service turnup leads to quicker time to revenue and quicker revenue ramps. Slide 12, what are the top AI use cases? We expect artificial intelligence to be used in a number of OEM areas: network resource planning and optimization, fault prediction and correction, self-optimizing networks, and predicting and avoiding network congestion. In addition, there is a bit of a network-based focus here, but the network element layer is only a piece of it. AI also has to include the service delivery layer. So OSSs and BSSs and service orchestration will play a role. And CSPs will need to take an end-to-end approach to automate service and network flows across multiple domains. So we believe that big data and analytics and AI will have a role to play in supporting the future operational paradigm. And slide 13, optical networks are comprised of transmission, optoelectronics, and the fiber plant. So network equipment components have a life cycle, and with being able to track more and more of the optical performance parameters, power levels, bit error rate, folks can actually get a sense of how a particular piece of equipment is doing. And a particular piece of equipment is prematurely aging, then the teams can get replacement equipment in place and change it over before we hit critical service affecting fault situations. And then the fiber plant itself, the fiber plant resides in very, very harsh environments. All kinds of threats assail the fiber plant. There can be seismic activity, electrical storms, extreme temperature variation. There can be heavy wind loads on aerial fiber. Vehicular traffic and rail traffic can be quite close to fiber rights of ways. So all kinds of things can have an impact on the actual fiber, which can affect the optical performance. And with more and more telemetry data, this can be paired with environmental data, and taking a longer time series view, we can look at this historical data and look, for example, at a particular type of environmental event in the past. If this event had an impact on optical performance and we see this kind of environmental event building in the future, we can take preemptive steps to move the traffic over before it's service affecting. So to conclude on slide 14, we are on a journey to a closed loop automation world. We have orders of magnitude more telemetry and network data. We have a framework for collecting, processing, analyzing network and service data to detect trends. We have new analytics tools and machine learning capabilities. We can use these to leverage these to create some insights, and the industry is striving and moving towards a world of closed loop automation. So thank you very much for listening, and hope to see you again in person in the near future.
Okay, thank you, Ian. So we're just going to take a brief pause here, and we're going to turn our attention to our first live poll, which you should be able to bring up here on the screen. This one. Do I need to publish? Just bear with me one moment. Yes, so you should be able to see that now. The first question is, which of the following is the most appealing in your pilot optical transmission network automation? Is it service automation, BSS OSS controller interconnection, or is it maintenance automation, AI-enabled health prediction, optimization, and troubleshooting in advance, or is it resource automation, online resource planning and delivery, or is it restoration automation, proactive rerouting, and protection against multiple fiber cuts? So I'll just give a minute for some answers to come in on that one. So again, those options are service automation, BSS, OSS controller interconnection and automatic service provisioning, maintenance automation, AI-enabled health prediction, optimization and troubleshooting in advance, resource automation, online resource planning and delivery, restoration automation, proactive rerouting and protection against multiple fiber cuts, or is there some other option that you would like to include there? So again, which of these options is the most appealing in your pilot optical transmission network automation? Okay, well, I can see that quite a few of you have responded, and interestingly, the biggest percentage of you have gone for the first option, which is service automation, BSS, OSS, controller interconnection, and automatic service provisioning. So if we can just go to Henry Cho from Huawei here. Henry, what do you make of those results?
Okay.
So as I say, the majority of the users have gone for the first option there. What do you think of those results?
Hello? Can you hear me?
Can you hear me? Yes, yes, I can hear you.
Okay, let's start. Okay, good.
Okay. Okay, so in the optical industry, automation is now no longer an if question, but a matter of when. So Huawei's Henry Cho is about to outline 4-dimensional automation and how it is reshaping smart operations and maintenance in optical networking. And so Henry, we're ready whenever you are.
Okay, good morning and good afternoon, everyone. I'm Henry, the CTO of Huawei NCE Transport. So today it's my best honor and pleasure to share and discuss with all of you about our thinking and ideas of new operation and maintenance of the optical network. So this is the first page, and as we know that the network is becoming more and more complicated, and on the other hand, the business need to move and more fast and agile. So as mentioned in Iran, Mr. Iran just mentioned, that's the automation. I think that can deliver the operation cost saving while the protecting and growing the revenue. And meanwhile, the AI is I think that's the closed loop. The AI is a central pillar in the operators and the digital transformation strategies. So in this page, I will share our solution, the Huawei, the 3-layer solution for the explosion for the new maintenance of the operation of the optical networks. So the first layer, you can see the first layer is a device. That's we can see that it integrates the sufficient sensors and to provide the second level sampling of the sufficient the data connection. And the second is OXC to provide ASON 2.0. We call it ASON 2.0. And so that's liquid OTN. That's to provide the flexible and make the hard pipe to flexible, make it flexible and more easy to more improve the efficiency of the network ratio. And the second is a network layer, and we also use integrated the AI. I think that is enabled by the iMaster NCE, so which is provided by Huawei. And in this component we call it maybe it's the brain of the network, and then integrated the manager, analyzer, and the controller, and to implement the closed loop automation. And the up layer is the remote, the cloud layer. And in this, that is two parts. First is iMaster NCE, which is provided by Huawei, and to provide the model training and to provide a large number of data from the global experience. And the other is IT and some OSS systems provided by the carrier. So based on this, basically that's on the based on this architecture, this solution, we have achieved that's 4 automations. That's first resource automation and achieve the TTM reduced from week to day level, and the service automation to provide the commercial operation, and even the maintenance automation to improve the efficiency of operation and maintenance by 30%. And last is recovery automation based on the ASON 2.0. Okay, please, next one. Okay, I will introduce the 4 automations one by one, and the first is resource automation. I think the challenge is definitely is very clear, and for all of in the industry, that's today that's first resource invisible and the low utilization, and to cause the long manual check for the resource, and it's totally the manually. And second is no accurate planning method, and cause urgent PO. That is it's lack of the forecast of the resource. The second is that planning and the deployment is totally separate. So we need to a lot of interaction of a human. So according to this challenge, and just I mentioned, there's a 3-layer solution of Huawei. So on this perspective, resource perspective, we can provide the 3 capabilities. The first is multi-dimension resource visualization. So firstly, we make the resource visibility. So this is, I think that is a foundation of all other capabilities. So we can achieve the resource utilization up by 20%. And based on this resource visualization, and next one is worldwide capacity prediction. So we can, based on the AI and the historical data of the network, and then we can make a predictive and forecast of the network capacity. And then that is from we can switch from the passive model to the proactive expansion, and to reduce the emergency expansion and avoid the urgent PO that make the shorten the TTM. The target is shorten the TTM. And third one is about the online planning. Just I mentioned that's today that it's situation is that the planning and the deployment is separately. So we provide the online planning and make the consistent of the resource. And our idea is that planned as deployed. So that is totally automatic. So in this way, we can reduce the also reduce the TTM and can make the to improve the efficiency of the service provision. Okay. Next one. Okay, the second one is the service automation. So after resource ready, and then we are go to the service. So current challenge is that we can see that from Gartner, be more agile to support digital business through API. So actually, I think that's in current situation is that for the carrier, not only the carrier but also the vendor, the talent, that is maybe a lot of the silo or systems to provide the operation, but not to facing the business, So for the carrier, I think that it's much more focused on the Azure for the Azure of the OSS integration. So the other object is to reduce the cost of the integration. And for the talent, that is about the experience, real-time experience, and myself experience. That is it's a future-proof experience about this, like IT. So for this automation, service automation, we can see firstly, that's based on the NCE, iMaster NCE. We can provide a lot of built-in use cases like latency map, agile provisioning, SLA, and intelligent alarms and health prediction, etc. Like this kind of a lot of this kind of future-proof capabilities. And on the other hand, very important is how to provide this capability to the upper layer systems. So we provide the ACKN APIs, the sufficient API to the is based on the SDN standard, and make the upper layer OSS or applications or other IT systems, make it the faster integration, agile integration, and can achieve the capabilities cover the whole business life cycle. So we can see here for carrier, not only both carrier and talent from pre-sales, in-sales, and after-sales, we can provide the full life cycle business use case and capabilities. And at last, today we have already achieved more than 8 OSS integration partners and 25 project integrations experience. And 30 is the integration into the production and the operation process, driving the product and operation upgrading. So that is for the service automation to achieve e-commerce operation. Okay, please, next one. Okay, the third one is maintenance automation. When we have provisioned the service, and then we will need to maintain the guaranteed the service, the quality of the service, and then that's maintenance automation. So here, that is again, we can see this is 3-layer solution for NCE for the network automation. So that's we can see that's some more detailed information about the 3 layers. So first layer, and for the that's we have achieved the AI chipset inside in the device level. We have integrated the AI acceleration ASON 310, this kind of chipset. And for the cloud layer, that's we can see that we have deployed the AI data lake to achieve that big data, and the modeling training. Just I mentioned that can provide that's accurate the data modeling, and then input to network the NCE the iMaster NCE, this layer. So I just mentioned that the iMaster NCE is like the brain of the network. So it use it can make a digital of the the digital twin of the physical network by the how do you say this sufficient sampling data from the network, and then use to coordinate of the cloud, the remote cloud of the data model, and then to achieve the closed loop automation to get the intelligent maintenance. So the up layer, we can see based on this solution, we have already achieved this kind of use cases. That's from the before faults and after faults. They covered all these kind of scenarios, the 4 scenarios. So fault simulation, health visibility, and health prediction. That is for all proactive, the forecast of the network, and the smart incident management. That's some achieved. That's root cause analysis, root cause service impacting analysis, something like this. And that is the after fault. So in a word, that's our solution. That's just 3 layer, and use the ABC technology, the artificial intelligence, big data, and massive computing. All these future-proof technologies are embedded in our solution and achieve this improving all operation and maintenance efficiency by 13%. Okay, please, next one. Okay, that is the last one about the recovery automation. So as you know, that in optical network 2.0 era, transmission network evolved from the down pipes to service networks, and directly provide the high value users with a new service such as the premium private line and the premium videos. And these new services and architectures of transmission network, optical networks, drives the evolution of ASON 2.0. So these architectures and also protocols or algorithms and hardware innovated by upgrade 3 key capabilities. So the first capability is ASON 2.0 achieved fast service recovery and ensure the high service availability. Okay. The rerouting performance is great improved, and the rerouting time we can see here that's for civil level protection is shortened to hundreds of milliseconds at the electrical layer, and for the optical layer it's also the second level rerouting. A second capability is it's about the flexible large network management and the breakthrough the network scale in limitation. Currently there is 800 network elements for the electrical layer, and 115 rodent sites for optical layer. So we will break through this limitation. And third and the last one is and also is the basic point is that ASON 2.0 has AI based intelligent control capabilities. With AI technology, we can see that ASON can implement the digital modeling of the analog optical networks and build the visualized and predictable smart digital network optical network. So that is the last the fourth automation. So I think that is all for my presentation. Thank you very much for your listening. Sorry, we can't hear you.
Sorry, sorry about that. Thank you very much, Henry. I'd just like to remind everyone that you can still vote on the poll that you can see there, that you can see on the right-hand side of your screen. And next, we would like to turn to Yin Zhang, who is going to explain how China Telecom is turning to resource automation to make optical network resources more visible, predictable, and expandable, all online. So Yin, we're ready when you are. Hold on just a moment. Should be able to get through to him.
Good morning, everyone. Today, I would like to use this opportunity to share with you something about SmartLink products and some intelligence assurance products. Before that, let us talk about why we want to develop these products in the first place. As we know, operators have many methods to manage resources. However, these methods can no longer keep up with the network O&M requirements. Optical networks pose higher requirements on service provisioning, resource assurance, and troubleshooting. Against this backdrop, we worked closely with Huawei in product and service development. I'm happy to share some details with you. Let's move to the next page. First, I would like to introduce our SmartLink product, which is the world's first OTN premium private line product and was launched at the end of 2018. Before we developed this product, operators used similar devices and technologies and provide similar services. In this case, there is no difference no matter which operator or network you choose. We ask ourselves, why should customers choose Beijing Unicom and not other vendors? What unique advantages and what more services can we offer? With these questions in mind, we gave an in-depth definition to SmartLink. First, it must be secure and of good quality. Therefore, we use the ASON technology to protect services from multiple fiber cuts. Second, it must support self-management, which has been implemented in many internet companies and OTT vendors, but not in conventional operators. We wanted to improve the self-management capability in SmartLink to a whole new level to allow users to choose, manage, and maintain their services on a self-service portal. Third, it must be agile. Service handling and adjustment used to be a prolonged process. It takes days to provision or adjust services. This is way too slow for people who are used to the speed and efficiency of the internet. Fourth, the latency must be low. Private line services are delay sensitive. However, it is challenging to maintain low latency on a large network unless we have a clever design. Last, it must do network visualization or service visualization. We opened our network capabilities to allow users gain visibility into their services through our BSS and OSS and management domains. This is one of the goals in the first place when we decided to develop this product. Now, let us move to the next page. On this page, we can see that the resource assurance system and service provisioning are connected. The entire service provisioning process includes network design and planning, engineering, network provisioning, and service provisioning. The sales personnel collect requirements and assign service tickets. Then the orders are handled and resource planned, including network and service design. This is a long process. In the engineering phase, we need to implement what we have planned on the network. Then, services are deployed through automatic service provisioning or service automation. In the past, the planning data, engineering data, and live data are separated, and the three types of data are handled by different people in different phases. The data is manually exchanged through Excel documents or reports. This can hardly satisfy the expectation of customers. Actually, we found that the optical layer of the PEOTN network is different from the conventional WDM network. Conventional WDM devices are mainly used on long-haul backbone networks. On such networks, the channels and services are predictable and network changes are not frequent. However, data and services on local networks are frequently changed. When WDM devices are deployed on local networks, conventional OTN management methods no longer fit for purpose. To address these challenges, we use an app in the NCET system to synchronize and visualize the three types of data. The three types of data are now visible to all O&M personnel so that resources can be rapidly assigned and services can be quickly deployed. Now, let us move to the next page. Conventionally, these three types of data are maintained by different O&M personnel, such as resource scheduling, planning, design, and service delivery and commissioning personnel. Upon receiving service requests, the planning personnel plan services using a planning tool. This may take several days. Then, the planning personnel send the planning and design documents to the engineering personnel through Excel documents or reports. Then, the engineering personnel construct the network based on the planning and design documents and schedule services. Finally, the information is manually transferred to service provisioning personnel. During service provisioning, manual configurations are required to complete OCH, service provisioning, on the optical network. This is the conventional way. In the intelligent optical network, we did not remove any process. We just made them automatic and intelligent. The three types of data are integrated and streamlined. In this way, planning, construction, and service delivery can be completed in minutes. In addition, NCE can automatically adjust OCH parameters. With these functions combined, we can complete service provisioning within 1 day after receiving a service request. Now, let us move to the next page. It is not enough to build a good network with fully integrated and intelligent management systems. The network itself must also be simplified. The PEOTN network of Beijing Unicom was constructed in 2015, starting from the core layer and then to the aggregation and access layers. Back then, we used the OSN 9600 ROADM system during the network construction. In 2018 and 2019, we saw the advantages of OXC devices. We gradually replaced the 8 ROADM systems on the core network with OXC devices. This is the world's first in which ROADM devices on a live network are replaced by OXC devices. The upgrade process was smooth. We replaced all the ROADM systems on the core layer with OXC devices. After the upgrade, we built a better network with fewer chassis and fiber connections and lower power consumption. At the same time, we also inherited and upgraded the original ASON network, which greatly improved the resource scheduling capability at the optical layer. To make the optical layer self-healing, we deployed an optical layer ASON network at the very beginning on the ROADM network. In this way, fewer optical layer boards and network configurations were required. In addition, ASON's protection levels from diamond to silver provide better service recovery capabilities and improved the resource utilization to 90%. The total power consumption was reduced by 57%, links by 77%, and patch cords by 56%. This not only simplified the network, but also reduced possible fault points. Now, let us move to the next page. Last but not least, be reminded that automation is a progressive process. Resource automation is only a part of a larger O&M automation. The other O&M parts are just as important as in the service, maintenance, and recovery or optimization automation. Only that in today's presentation, my focus is on the resource automation. Resource automation gives us better control over resources. This is the foundation of network capability exposure. In the future, we will intensify our service and maintenance automation efforts. We will use more AI and service recovery technologies to automate network operation. That is all I have for today. I hope it has been useful. Thank you.
Okay, thank you, Yin. So now with service automation already underway in the real world, we're going to head to Bangkok now to hear from Kawanan Pachanun, whose focus today is surface automation and differentiated service level agreement, monetization for cloud private lines rather. Kawanan, it's over to you.
Thank you. Let's make a start. I should probably start by introducing myself. I'm Kawanan Pachanun, Vice President of CAT Telecom. My role in organization is to develop data service in order to meet customer requirement and expectation. Today, I will present about automation and self-service provisioning experience improvement. Next slide, please. First, for those of you who don't know CAT Telecom is the state enterprise in Thailand providing telecom and IT services. Our annual revenue last year is around 87,000 million Thai baht. We have around 5,000 employees. Our core network is nationwide with more than 32,000 kilometers of fiber optic cable. Currently, our core network supports up to terabit per second. In addition, we have 5 submarine cable landing stations, 3 satellite earth stations, plus 8 data center holding all regions of Thailand. Next, please. Due to the situation of digital disruption and trends of technology, we rethink our brand and the identity. We conclude to be the catalyst who brings achievement to customers through technology. We mainly focus on customer satisfaction. As each customer segment needs different solutions, we offer solution customization for each segment. We categorize customer segment into 4 base groups. Native is mass market, which we provide smart home solution, high-speed broadband, internet, and mobile services. Nation is government customers, which I will elaborate more in upcoming slides. Network for operator and provider. We offer Thailand Internet Exchange, which is largest L2 standard Internet exchange in Thailand. Last is enterprise for business corporation. We have smart solutions for each vertical, Internet of Things solution for industrial automation, plus cybersecurity service offerings. Next, please. Now, let me talk about government customers. As government decided to promote digital transformation in the country, several projects have been launched. Government is the first segment that CAT offers service automation and self-service provisioning solutions. To give you some background, Thai government launched Thailand 4.0 Digital Thailand Plan to achieve 3 main objectives. First is to transform production from commodity to innovative products. Second is to convert industry-driven activities into those driven by technology, creativity, and innovation. And third, to change the focus from producing products to providing services. That is a long-term plan of 20 years. Now, we are in the second phase to ensure every Thai can reap the benefit of digital technology. After implementing Thailand 4.0 strategy, Thailand get higher rank in e-government, e-participation index, and as shown in the slide, also our GDP is growing more than 30% in 3-year time. Refer to the information from the United Nations. Next slide, please.
Sorry, 1 second.
Here are the government projects which CAT support to drive Digital Thailand 4.0 plan. First is Government Data Center and Cloud Services. It's a platform for all government agencies to utilize cloud computing and big data analytics to serve all Thais. Second is Phuket Smart City. It's the implementation of Internet of Things solution in the most popular destination for tourists. Third is Digital Park Thailand. It's the dedicated land for foreign investors and talents to create, share, and distribute knowledge and technology innovation to the world. Next is ASEAN Digital Hub. It's the national bandwidth connectivity in Southeast Asian region. Another project to be launched soon is Thailand National Single Window for Thai customs to accommodate B2B, G2G, B2G transactions, e-payment, and also logistics. All of these projects require stable fiber network, high reliability, high bandwidth, low latency, and short time to market. Next slide, please. Currently, for ASEAN Digital Hub, we built the first end-to-end next-gen OTN network and controller in Thailand. It is a nationwide network with 99.99% availability by automatically switched optical network technology. It guarantees ultra-low latency, intelligence, and agility with real-time visibility for proactive service support. The user acceptance test of the network cloud engine was done last month. We plan to deploy the engine for the government data center and cloud service project. With this engine, which is the first network automation and intelligence platform, we believe it will ensure our operational excellence. Next slide, please.
Sorry, bear with me 1 second, please.
Okay. Looking at the technology trends of cloud and artificial intelligence, we see that service automation will be one of the key success factors to support digital transformation in Thailand. Network and service are all automated. Interesting feature offering include latency automatic measurement, one-click bandwidth on demand, and automatic route selection, which we can offer right away. In the future, there will be development to allow mobile application, automation, order to service, and service status self-check. This will differentiate our service to competitors. It brings better experience to customer. At the same time, the solution is also cost-effective for our organization as a provider. All right, this is the end of my presentation, and thank you very much for your attention.
Okay, thank you, Kawanun. So finally, we're going to turn to Jinming Xu, who is going to from China Unicom, sorry, who is going to outline the benefits of maintenance automation as we discover how predictive artificial intelligence is driving network optimization. So Jinming, whenever you're ready.
Yes.
Hello. Okay.
Thank you.
Over to you. Sorry, I can't hear you at the moment.
Yes, yes. Oh, okay. Hello, everyone.
Hello?
Hello?
Oh,
can you listen me?
Yes, yes, we can hear you. Please go ahead.
Oh, okay. Hello, everyone. I am Xue Jinming. I am from Jiangsu Unicom. Today, I'd like to share with you the innovation and the expression in mathematical O&M. Okay, let's start. Page 2, please. Currently, a new wave of digital revolution is sweeping the world, governments, and enterprise, and actively combining their industry expertise with new digital technologies to reshape their business models and service competitiveness. However, the digital transformation of the governments and the enterprise requires two types of infrastructure, cloud and connectivity. Therefore, Jiangsu Unicom is building a cloud network integrated service system and shifting our focus from connectivity to value-added service. We're building a premier network with low latency, higher bandwidth, and high availability for key governments and enterprise customers, and advance the synergy between clouds and networks. However, cloud network integration poses higher requirements on network O&M, since several quantity depends on network quantity. To ensure network quantity, Jiangsu Unicom uses new technologies such as SDN, big data, and AI to automate O&M and service delivery, digitalize service and network quality, and transform O&M from reactive to proactive. Page 3, please. In 2020, Jiangsu Unicom and Huawei set up to joint O&M innovation team to automate O&M through digitalization and AI technologies. The team have set 3 innovation goals. The first one is optical network health assurance, which help to ensure the health of optical networks. To do so, we need to digitalize the optical net quantity and predict faults to transform maintenance from reactive to proactive. The second is evaluated the network availability to build high reliable network as new interest in the infrastructure and promote network service synergy. The third is monitor and analyze the traffic in hard pipes for network maintenance. Page 4, please. Regarding our innovation in optical network health assurance, as you know, optical fiber are the cornerstone of modern network communication. With the rapid development of all optical transport technologies, the capacity of the signal fiber has reached 48 TBs. A fiber may carry service of a large number of customers. Therefore, the stable and health optical network is very important, particularly for primarily provide line of government and enterprise customers. Optical fire force has a huge impact on the quantity of optical transport network. Factors such as environmental changes, damage caused by animal, component aging, and fiber core degradation with deteriorate the health status of optical fiber and the quantity of optical signal transmission. Since optical fiber are passive, the monitoring, prevention, and the location of optical fiber faults have always been difficult. Therefore, maintenance is performed only after a fault occurs. Huawei's OTN Plus iMaster NCE solution uses AI, big data, and machine learning technologies to accurately monitor the optical net performance, including the health status of fiber and OCH trace, predict the trends in health status, and identify quality risks and locations. This transform maintains from reactive to proactive and improves O&M efficiency and network quality. Page 5, please. We have deployed Huawei's iMaster NCE and OTN device on the network. We monitored 6 sites, 14 directional OTS fiber, and 4 bidirectional OCH channels using the Optical Network Health Assurance app of NCE for 2 months. During the 2 months pilot run, the Optical Network Health Assurance app provided a warning about multiple sub-health fiber and OCH trace, and located the degradation and interruption points of multiple fibers. Facilitating proactive O&M and improving network ability. Next, I will show you some positive result. Page 6, please. As you see, the Optical Network Health Assurance app accurately predicted the health deterioration trends of OCH and fibers, and provided the severity from minor and critical, and warning time to leap faults in the bud. Page 7, please. On this page, we can see that using the OTDR technology, the Optical Health Assurance application can locate deterioration and fault points automatically. This significantly improves troubleshooting efficiency. Page 8, please. The Optical Network Health Insurance application monitors fiber core quality in real time, uses big data analyzer and backtracking capabilities to identify potential risks. For example, identification, degradation after cutover, and signals never fiber interruption. Page 9, please. After using the Optical Networks Health Assurance solution, improvements have been made in the rate and efficiency of degradation, identification, the automate O&M reduce workload by 642 person-hours each year. Optical network health prediction is expected to reduce fiber core faults by 30% and the network downtime by 30%. Jiangsu Unicom will continue to explore and practice evaluating solution for intelligent O&M. Accelerate the application of AI in optical networks and promote intelligent and automatic O&M to improve O&M efficiency and network quality and provide high-quality network service for government and enterprise customers. Okay, thanks all. I have shared today. Thank you for listening. Thank you.
Okay, thank you, Jinmi.
Thank you.
So now, before we end with our interactive Q&A session, we're going to move on to another poll. So our second poll question, as you can see here, and we'll try and get that published for you. So you should be able to see the question here now, which is, which of the following is the biggest challenge or challenges to your transmission network O&M? So the first option there is automation between the OSS, BSS, and controller is insufficient, and optical transmission services are mainly provisioned manually. The second option is online planning capabilities are insufficient, and service provisioning period is long. And the third option here is predictive and proactive maintenance methods are underdeveloped. Or the fourth option here is services are frequently interrupted by fiber faults. Or you may feel that there's another challenge, so you can select the others section there. Henry, if I can come back to you briefly to get your opinion of the results of the first poll. So if you remember, we asked which of the following is the most appealing in your pilot optical transmission network automation, and 37% of the people polled, which was the highest number of people, selected service automation, so BSS, OSS, controller interconnection, and automatic service provisioning. So what do you make of those results? Is that something that surprises you, or is that something you would expect to see?
I think that's no surprise. I think yes. You know that the automation that's especially for the service automation, I think that, for my opinion, that it's different, divided, consists of a different layer. So that's for the BSS and OSS. That is for this accommodation of the constructed for a long history of each carrier and operators. And for this, that is very huge workload to have some evolution for the OSS and the BSS. So that is really complicated and really very workload. So I think that is it's a long journey for us. I think that I totally agree with this opinion about this service automation. Maybe for BSS, OSS, and controlling interconnections, it is most important. I think so. Yeah.
Fantastic. Thank you for your feedback on that one. So I see in the second poll where we just asked which is the biggest challenges to the optical transmission network O&M. So far, a lot of people have comment said that the automation between OSS, BSS, and the controller is insufficient, and that the optical transmission services are mainly provisioned manually. So again, is that surprising to you? Is there any other result you would expect there, or?
I think that it's the same logic just I mentioned. Exactly. There's not only the interconnection and but also the standard and the interface, and so that is really the pain point of the automation. So I can share a very short story. You know that in West Europe, that's a lot of I see that's a couple of very big operators. Their strategy is to build the NAP. What is NAP? The network as a platform. And some others, let's build the similar concept, the NAS or API first. I think that is different names, but the logic is quite the same about this. How to provide the sufficient and very easy and very simplified the API. How to make the integration. Sorry. How to make the OSS integration easier and agile and fast to help them to agile to create their business product, and also help them to reduce the cost of the integration and the maintenance. So I think that is yeah. I also the same logic. I agree.
Okay, great. Thank you. All right. Now we're going to give you an opportunity to ask the questions that matter most to you. So if you just bear with me 1 second. Oh, yeah. So now it's time for the Q&A section. So this gives you an opportunity to ask the questions that matter to you, and you can use the chat box, which should come on the right-hand side of your screen there. So we're just going to take a look and see what questions we've got so far. If you just bear with me 1 second. Okay, so the first question we have is, are NCEs often deployed in transport networks? So Henry, would you be able to field this one for us?
Okay, about this commercial deployment, I think that's you know, that's the first version of NCE transport was released in 2018, and by the end of June this year, and more than 600 sets of NCE have been deployed in the global carrier market, and the forecast is that by the end of this year, and more than 1,000 sets of NCE will be deployed for commercial, include in Europe, Middle East, Africa, Asia, Asia Pacific, and also Russia, Japan, and etc. And of course, China, include China region. I think that is the current situation. Yeah.
Okay, great. Thank you. And we have another question here where a user asks, can health prediction features be directly applied in my network without any artificial intelligence retraining?
Oh, I think that is a very, very good question about this AI. I think that everybody is having interest on this topic. So basically, AI application on network need you know that machine learning and model training, and for the large number of data. So these trained data models are verified and on the network. So during the generalization process, so that is from the limitation to the unlimited. This accuracy, be honest, that it will decrease. So, but according to the joint verification between Huawei and China Unicom, just our customer shared. So, as our experience, that accuracy can reach over 18%. So, of course, I think that this accuracy has also have the positive impact of the network maintenance. I think this another additionally that's so I think that this case requires that OTN device support some second level and even the millisecond level data connection capabilities, and requires some software upgrade. Yeah, that is it.
Okay, fantastic. Thank you. And we have a third question here. It says, how does NCE support OSS to build unified resource management system? Is there any mechanism to ensure the resource accuracy and consistency between RMS and NCE?
Okay. I think this. I think that today we have mentioned about the OSS integration several times. This time, for this question, I think that's. I would say, firstly, I think Huawei believes that the automation is a development trend in the future, especially the automation of operation systems, support systems. So, just I mentioned, that's a lot of years of a combination of construction, operators, operation system have it's complicated. That's really complicated and really huge. So that's lead very hard to have some evolution. So our idea from Huawei perspective, our idea is to open the network. So based on NCE, can open the network capabilities to the OSS through the rich northbound interface that I mentioned, the API first, and supporting the traditional like COBA, XML, but both the traditional and the future-proof, the RESTful HTTP interface. So not only the traditional, but also the future-proof, the northbound interface to helping the carrier to quickly interconnect the NCE with the OSS and implement the automatic network operation. So that is our idea. So that is again, not again.
Okay. All right. Thank you very much, Henry, for your insight. I think now it's probably time that we wrap up this session. So thank you, everybody who asked questions. And I'm sorry if we didn't get around to answering yours, but if we didn't get to answer it live and in real time, don't worry, we can get back to you by email to respond that way. So thank you very much for your time today. Thank you all for joining us. And thank you to our speakers today. Thank you to Ian. Thank you, Henry. Thank you, Kawinan. Jin Jiang and Jinming Shi. So thank you all for your insight, and until next time, take care and goodbye, everyone. Thank you.
Thank you.
Okay, thank you. Bye-bye.
Bye bye.
Thank you.